Hi, we are looking at Chapter 10, Section 5, Trigonometry and Area. And what's going to happen in this section is we're going to learn one new formula, but we're also going to learn how to use trigonometry to help us solve for areas or to solve for missing angles in figures that we already know about. So, right here we have a regular pentagon. The side length is 10, and we are looking for the area of this regular pentagon. Well, we learned in previous sections that in order to get the area of a regular polygon, the first thing I want to do is take 360 degrees, divide it by the number of sides, and that gives me 72 degrees. I also want to draw in the center of this figure, and I want to draw in 2 radii to create an isosceles triangle. I'm going to write over here, I'm going to draw a second triangle, and I'm going to say this is 72 degrees because that's what we just found out, that the central angle is 72 degrees. But then what happens is the apothem comes down. It's perpendicular here. It bisects this into 5 and 5, and it also makes this a 36-degree angle because the 72 gets bisected. At that point, I know to calculate the area of this object, I will need to use the formula half apothem perimeter. Right now, I don't know the apothem, but I do know the perimeter is 50. So we need to find that apothem. So in order to find that apothem, I'm going to call it x. And using this little right triangle, I'm going to say that the tangent of 36 degrees is equal to 5 over x. Using algebra, I end up with 5 over tan 36 is equal to x. I then use my calculator to get an approximation for that. So on your calculator, go ahead and do 5 divided by the tangent of 36, and you should end up with about 6.882. 6.882. So we go ahead and we write that down. If you didn't get that, maybe you're in the wrong mode. Double check. So that's the number that we're going to fill in right here for our apothem, and then we're just going to go ahead and multiply that out. So 1/2 times 6.882 times 50. And we end up with roughly, approximately 172, and this says to go to the nearest tenth, so we're going to round that to 172.1, and our units here are centimeters squared. And that is our first example. Again, I go about finding my central angle, I bisect it, I now have this little right triangle, I know the formula is half apothem perimeter, so I have to find the apothem and then I can proceed. Now, from problem to problem, you'll be given different things. You'll be given the radius, you'll be given the apothem. It just depends, and again, you can use trigonometry, though, to solve for the missing pieces you need to get the area of the, in this case, the pentagon. Okay, let's move on to page 2. Okay, on page 2, we have a new way to find the area of a triangle that uses trigonometry. So in order to use this area, you need to know SAS on your triangle. Okay, so that's a good thing to know. It's only going to work with SAS. And you'll notice you're using a different letter for each of these. So if we go ahead and apply that formula to this picture right here. We're being told that angle A is 50 degrees. We're told that AB is 12, and we're told that AC is 17. Notice, side angle side is what you've been given, and you're asked for the area. So, the area is going to be 1/2 the two sides you've been given, so times 12 times 17, and then times the sine of the angle you've been given, which in this case is 50 degrees. So you take out your calculator, you go ahead and multiply those all together. So I'm just doing the nicer numbers first, and you end up with 102 for this part, sine 50, and then we're going to go ahead and multiply this out so we can get, excuse my symbol here, an approximate area. So go ahead and punch away, and you should end up with about 78 point to the nearest tenth. Oh, I didn't mention that, but let's go to the nearest tenth, 78.1, and we don't have any units, so we're just going to say square units. Okay, let us move on to the examples on page 3. Okay, so on this page, page 3, we are looking for the area of a regular decagon with sides of length 4 inches. So I've drawn the decagon, and I've drawn one of the isosceles triangles, and then I've just drawn it larger over here. What you want to keep in mind is the fact that sometimes it's not going to be possible for you to draw out a decagon or a 20gon or whatever. So rather than doing that, just draw an isosceles triangle. What I like to do is I like to just put edges on it, remind myself that I'm dealing with 10 sides, not just the one side that I see here. So according to this, the side is 4 inches. So I have my 2 radii, and what I want to do now is drop the apothem in. When it comes down, it bisects the side of the polygon. I also want to take note of the fact that since I have the side is 4, that means my perimeter is 40. So I also know that the vertex angle on a decagon, one of the isosceles triangles, will be 36 degrees. That 36 degrees gets bisected into 18 and 18. And so with that in mind, the last thing I'm missing is the apothem to find the area. So I'm going to use trigonometry to get the x, and that would be the tangent of 18 is equal to 2 over x, opposite over adjacent. At that point, algebra tells me x will be 2 over tan 18. Okay, that's the exact value. I now know my area is going to be half apothem perimeter, which will be half of 2 over tan 18 times the perimeter of 40. That simplified, half of 40 will be 20. 20 times 2 will be 40, and my exact answer for the area is 40 over tan 18. To change that and get an answer to the nearest thousandth, I'm going to do 40 divided by tan 18 on my calculator, and we will see that our answer should be about, again, sorry about that, 123.107. And our units here were inches. This is square inches for that area. Okay, we are going to skip example 2, and we are going to continue on to page 3 and work on example 3. Okay, on example 3, we are asked to find the area of this triangle. Again, notice side angle side has been given. So our formula is, again, using any version you'd like, half AB sine of angle C. So the A and the B are the two sides I've been given. So we go ahead and we fill those in with 11 and 8. And then it's going to be the sine of the angle we've been given, which is 62. Cleaning that up, I end up with 44 sine of 62. And then I go ahead and on my calculator figure out what 44 times the sine of 62 is and round it to the nearest thousandth, and that will get you 38.850 after rounding. And our units this time were centimeters, and so it's centimeters squared. All right, we're going to go ahead and stop there. Stay classy, and I'll see you in geometry.